Cement. It's literally the invisible foundation of our world. We pour something like 4 billion tons of it every single year.
It's an unbelievable number. And if the cement industry were a country, it would be the third largest emitter of CO2 on the planet.
Right. We're talking about, what, 8% of all human-generated emissions?
Around that, yes. And what's really wild is that the basic technology we use for it, Portland cement, it's been pretty much the same since the 1820s.
For 200 years.
200 years of the same recipe, the same heavy industrial process.
Well, today we are taking a deep dive into the revolution that is finally breaking that cycle. This is the Kildvrimi, or the clay revolution, and it's being spearheaded by some major players, like Cimpor.
And this isn't, a minor tweak. We're not talking about small efficiency gains. This is a fundamental redesign of the material itself.
It's a pivot to things like calcined clay or calcined kill.
Exactly. Abundant materials that promise to completely overhaul the energy and emissions profile of manufacturing one of our most essential materials.
So our mission today is to really understand the tech here. What is LC3 exactly? We also need to zoom in on the performance metrics, the numbers on emissions and energy cuts that Cimpor has already proven.
And then we can explore what this huge shift, backed by giants like Taiwan Cement, really means for the future of, building anything.
Okay, so let's get into it. Start with the problem. Traditional cement relies on something called clinker. Why is clinker the villain here?
Well, the problem with clinker is really twofold, and it's why the process is so incredibly carbon intensive.
Okay.
To make clinker, you have to heat limestone to just extreme temperatures. We're talking around 14,450 degrees Celsius.
That's hotter than volcanic lava.
It is. So the first source of CO2 is obvious. It's the massive amount of fossil fuels you have to burn just to get the kiln that hot.
Right, the fuel.
But the second source, and this is the really tricky one to solve, is the chemical reaction itself. When you heat limestone that much, the rock literally breaks down. It's a process called calcination.
And that releases CO2.
It releases the CO2 that was chemically trapped inside the rock. It's what we call process emissions. It's unavoidable.
So even if you powered the whole plant with, 100% solar energy, you'd still have those emissions from the rock itself?
Precisely. And that process CO2 accounts for about 2/3 of the clinker's total emissions. It's baked in chemically.
Okay, so that's the problem. How does this new LC3 technology get around that?
So LC3 stands for limestone calcined clay cement. And its genius is that it gives you a way to drastically reduce how much clinker you need in the final mix.
You're swapping it out.
You're swapping a big chunk of it out for a blend of limestone and, crucially, calcined clay.
So why is calcining clay so much better?
It's the heat. Clay needs far, far less of it. We're talking calcining temperatures around, say, 700 to 850 degrees Celsius.
So about half the temperature of clinker?
Roughly, yeah, which immediately slashes the amount of fuel you need to burn. But critically, the chemical process of heating clay, you're basically just driving off water molecules. It doesn't release inherent CO2 from the rock like limestone does.
I see. So you're swapping a high heat CO2 releasing rock for a lower heat, abundant and sort of inert material.
That is the core technical leap.
Yeah.
And Cimpor has gone even further. They've developed their own proprietary version of this, which they call DO clay.
DO clay. The name itself, it sounds like it's about removing something. Is that related to the chemistry you just mentioned?
It is. It almost certainly refers to dehydroxylation, that process of driving off the hydroxyl or OH groups from the clay.
Okay.
Their technology is all about optimizing how they treat the raw clay and how they run the calcination process at those lower temperatures. The goal is to make that calcined clay as reactive and high performance as possible.
So they can use even more of it and less clinker.
Exactly. It's all about driving that clinker ratio down as low as you can possibly get it while, still making sure the final cement is strong and durable.
Okay, the science sounds promising, but the real proof is always in the performance data. What did Cimpor actually report? I know they shared results at the CUSCIT's 25 Cement Olympics.
Yeah, and the numbers are, they're industry defining. The headline figure they announced was a reduction of nearly 90% in carbon dioxide emissions.
90%. I mean, that number in heavy industry, it just sounds almost fictional.
It really does.
We're used to talking about, 5% here, 10% there, a 90% cut. You've essentially solved the core emissions problem of the material.
You fundamentally change the entire input-output equation. It's not just optimization anymore, it's a complete paradigm shift.
And what's crucial here, and why this has a real shot at scaling globally, is that it's also incredibly economic. It's a massive energy saver.
Absolutely. I mean, when you drop your core operating temperature by hundreds of degrees, the whole energy profile just transforms. They reported huge efficiency gains.
Like what?
Okay, so for electrical consumption, they reported a 60% energy savings.
60% less electricity needed. Given the scale we're talking about, that has massive implications for power grids, for OPEX, for everything.
And then there's the thermal energy, the direct heat for the kilns. Even there, with the lower clay temperatures, they reported savings of over 30%.
Wow. What's so fascinating is how these things stack on top of each other. You get, near total elimination of process emissions, huge fuel reduction, and massive electrical savings.
It completely transforms the cost structure. Suddenly, the most environmentally responsible choice is also the most profitable one in the long run.
That's the holy grail, isn't it?
It is. That's the key takeaway for anyone listening. This moves sustainability from being a line item, a cost center, to being a core competitive advantage. And they are backing this up with serious scale.
So what's their immediate target for capacity?
By 2026, their goal is to reach an annual capacity of at least 1.5 million tons of calcined clay production.
Okay, so this isn't some pilot project. They're building a global supply line for this new material.
That's the plan.
And what does that 1.5 million tons mean in terms of, actual CO2 taken out of the atmosphere?
Once that's all mixed into cement, it's equivalent to about 5 million tons of this new cement product annually. And that volume will allow for a CO2 reduction of up to 1.2 million tons per year.
1.2 million tons. That's a real, tangible global impact.
It takes it from an impressive lab result to something that can actually move the needle on a national and even global scale.
So this is clearly more than just a tech update. It feels like a total philosophical shift for a heavy industry company. What's the corporate strategy behind all this?
If you connect the dots, the leadership is very explicit about it. Sympor's chairman, Suchel Biek, he distilled their entire philosophy down to one statement. He said, "Green is the new gold."
Green is the new gold. That's powerful. It reframes this whole thing, not as corporate responsibility, but as the new source of economic value.
Absolutely. The company sees sustainability and digitalization as the two pillars of their entire business model. They know that competition now isn't just about the financial bottom line.
Right. It's about your environmental and social performance. That's where investors and customers are looking.
Exactly. And the chairman also talked about this being a time of regeneration, getting past this old idea of heavy industry as being dirty and static.
He mentioned redefining resources and our relationship with nature.
He did. The old model was, just maximize output, no matter the cost. This new model is about maximizing output while minimizing environmental impact, often by using resources like these common clays that we'd previously just overlooked.
And this isn't just talk. This isn't theoretical. They are already rolling this out across the globe.
That's the critical piece of evidence.
Yeah.
The source material confirms it. The world's first integrated calcined clay production line was launched in Côte d'Ivoire back in 2020.
So they didn't start in, say, Germany or the U.S. They started in the Ivory Coast.
They started where the raw materials are abundant and where the need for sustainable infrastructure is incredibly high.
And where did they go from there?
They quickly followed up with facilities in Cameroon, and the roadmap includes new plants in Portugal and Ghana.
So by that 2026 goal, what's the footprint going to look like?
They're aiming to be the world's largest producer of this material with 4 major dedicated facilities globally. It shows real confidence in the tech.
So this brings up a really important question. A 90% CO2 reduction sounds almost too good to be true. Are there trade-offs? Is this low-carbon cement weaker, or does it cure differently?
That's the crucial question for adoption, right? And what the research and the real-world deployments have shown is that, no, LC3 cement can actually achieve comparable and, in some cases, superior long-term strength and durability.
Really?
Yeah. There were early concerns about things like curing time, but advanced formulations have pretty much solved those. And the other huge advantage is that the right kinds of clay are geographically abundant all over the world. That solves a lot of supply chain headaches.
So the challenge isn't the performance of the material, it's scaling up and just overcoming inertia.
It's scaling production and convincing a massive conservative global industry to change the way it's done things for 2 centuries. That requires huge industrial backing.
Okay, so who is behind this? Who's funding this revolution?
Well, Simport itself is a big player, founded in Portugal. But they operate, along with Oyak Cimento, under the much larger umbrella of TCC Group Holdings.
Taiwan Cement Corporation.
That's the one. They provide the massive financial and logistical power you need to make a transformation on this scale actually happen.
And TCC is a huge name in global construction. How big are we talking?
They're the third largest global cement producer in the world, if you exclude the Chinese market.
The third largest.
They were founded in Taiwan back in 1946. Today, their total global cement capacity is about 112.5 million tons a year.
112.5 million tons. To put that in perspective for you, that's roughly the same as the entire cement production of Russia and Brazil combined.
It is immense scale, and their consolidated revenue in 2024 was around 4.6 billion euros. So this context is vital because it means we're not talking about some niche green startup.
No, this is being pushed and pushed hard by a global heavyweight.
Exactly. When a player of that size commits this hard, the entire sector has to take notice. It accelerates everything.
Absolutely. Okay, so let's quickly consolidate the key takeaways for you. We've seen how these technologies, DeoClay and LC3, use abundant clay to get away from that old high-heat, high-emission clinker process.
And the performance metrics are just staggering. I mean, they're the anchor points here. Nearly 90% CO2 reduction, 60% electricity savings, and over 30% savings in heat energy.
It's the definition of a disruption. It's better for the environment, and it's better for the bottom line.
And this whole shift, embodied by that idea that green is the new gold, it's proving that you can solve these huge industrial challenges with, fundamental redesigns, not just small tweaks.
And that revolution is already happening from Africa to Europe.
Which brings us to our final provocative thought for you to consider. The cement industry did things the same way for 200 years before a 90% emission reduction became a corporate reality.
So if this deeply entrenched carbon-intensive industry can undergo such a radical, profitable green gold disruption, which other foundational industries are next?
Think about steel, think aluminum, or even the huge ammonia and fertilizer industries. Which of them are poised right now for their own long overdue fundamental revolutions? How close are we to seeing green gold become the standard, not the exception, across the entire industrial backbone of our civilization?
That is the big picture question we leave you with. Thank you for joining us for this deep dive. We'll see you.